Rahim. Today we are with the lecture number 6. Here we have an example, very interesting one. We have two resistors R1 and R2, and we have two capacitors of zero point 0.1 microfarad and zero point 0.5 microfarad, such that its initial voltage V01 is 5 volt and V 02 is equals to 10 volt. The input voltage source is 100 volt and for time t is greater than or equals to 0. Now here we have IT, and this thing we want to calculate. Okay, first of all, what we have to do, we have to calculate R Thevenin and equivalent capacitance. So what is the equivalent capacitance for C equivalent? As you already know that whenever two capacitors are in series, so we will find out its parallel equivalent, just like resistor. So C equivalent will be equals to C1 C2 over C1 plus C2. So putting all the values 0.1 0.1 microfarad multiplied by 0.5 microfarad divided by 0.1 microfarad plus 0.5 microfarad, so it will be 0.0833 microfarad. So this is equivalent resistance. Similarly, the voltage across both capacitors plus minus, so that will be the sum of two voltages. So V across both capacitors, so that will be 15 volts. So I will write as V0. Now what we want to calculate next, we want to calculate R Thevenin. So how would we calculate R Thevenin? So the easiest method is to short this voltage source and open this capacitor source. So in this way, your R Thevenin will be the parallel sum of R1 and R2. So this will be equals to R1 R2 over R1 plus R2. So putting the values 30, as you already know, मैंने आपको एक सिंपल मेथड भी बताया हुआ है. So वो कैसे होगा, that will R1 inverse plus R2 inverse and whole inverse. So in this way you have 30 inverse plus 10 inverse and the answer inverse, so that will be 7.5 kilo ohms. So in our next step, we will calculate the time constant, tau. So tau is equals to R Thevenin times C equivalent. So this will be 7.5 into 10 raised to power 3, because that is in kilo ohms, into 0.0833 into 10 raised to power minus 6, because this is in microfarads. So this will be 0.000624 seconds. And by putting removing zeros, so we can have 624 microseconds. Now, we have calculated R Thevenin, we have calculated C equivalent. Now, what we want to calculate, we will calculate V Thevenin. So what is a V Thevenin? V Thevenin is between these two points. So again, we will remove the capacitors and again open our voltage source. So open our voltage source and reconnect the voltage source just like it was before. So our V Thevenin will be equals to voltage across R2. So we have R2 divided by R1 plus R2 times input voltage, and that is 100 volts. So this will be equals to 25 U of t, or we can simply write it as 25 volts for time t greater than or equals to 0. Now redrawing our circuit, we have V Thevenin, that is 25 U of t, Thevenin equivalent, that is 7.5 kilo ohms, and these are the 2 points where we have removed our circuit. So this will be a capacitor of value 0.0833 microfarad, and the voltage across this capacitor, initial voltage, that is 15 volts. Now so far we have all the data for our calculation. Now we will apply the standard form of equation. So that will be equals to Vt is equals to V0 minus Va e raised to power minus t over tau plus Va. So what is the value of V0? That is 15 volts. 15 minus what is the value of Va? Now Va is very easy to calculate, and this is equals to our source voltage, because in this circuit, when this capacitor will be fully charged, so this will becomes open and we will get 25 volt across this point. So Va is equals to 25 volts. So Va 15 minus 25 into e raised to power minus t over what is the value of tau here. So we have calculated this is 624 into 10 raised to power minus 6 plus Va, that is 25. So simplifying this equation, we will have 25 minus 10 e raised to power minus 1600 t, and this one is volts for time t equals to or greater than 0. How we got 1600? This is the inverse of 624 into 10 raised to power minus 6. If we take the inverse of it, this comes out to be 1600. So if we plot this equation, so this is time axis, that will be in seconds. Now here, this will be our initial voltage, and of course this is 15 volts, and this is our VA, this is our source volt. So if we plot this curve, so capacitor will start charging from this point. So this is the dotted line, and at that point we have 5 tau. We consider that up to this point our capacitor will be fully charged, so starting from this point and ending at this point, so the curve will be like this one. So this is the graph of our equation. So the demand of the question is to find out the value of IT. And we know that IT is basically the current that is passing through this branch. And we know the value of this potential source and this potential source. This is exactly same as in Thevenin equivalent. And this will be this voltage and this voltage. So to find out the value of IT. So replacing the values, we have IT, and if the source voltage in this diagram is 100 volt and the voltage across these two capacitors is given by the equation, and here we have this equation. This is equals to the voltage that is a function of time, and that is across the capacitors. So we have the values of 2 points. One is 100 volt and the other one is 25 minus e raised to power minus 1600t. So what will be the value of IT? So that will be VA minus VT, and divided by the resistance, and it's R1. Here you can see that the value of resistance is R1. So by placing these values, we have 100 minus 25 minus 10 e raised to power minus 1600t divided by 30 kilo ohms. So by calculating this value, we get our answer, and this will be equals to 2.5 plus 0.33 e raised to power minus 1600t, and that will be in milliamperes because the resistance was in kilo ohms. So this is our example. Now in the same lecture we will solve another example that is very interesting. Now you will start noticing that things are getting very easy and interesting. So in this next example we have an equation. Now the equation is Vc of t. This is the voltage across any of the capacitor, and you have 20 e raised to power minus 200 t minus 10 volts for t greater than or equals to 0. Now the demand of the question is to find out state variables. State variables. Now what are the state variables? So we have to find out the value of tau, time constant. We have to find out the value of VA. We have to find the value of V naught. And another demand of the question is at what time our VCT, that will be equals to 0 volts. So we must know or remember the generic equation, and that is VT is equals to V naught minus VA e raised to power minus t over tau plus VA for time t greater than or equals to 0. This is our generic equation. So comparing these equations, we have this factor. This is 20 e raised to power minus 200t. This should be equals to this one. And for this factor, this should be equals to VA. And this is one method. And the other method is we place t is equals to 0. When we place t is equals to 0, our equation will reduce to Vt is equals to V naught minus VA e raised to power minus 0 over tau. So this factor will become 1 plus VA. So we have V naught minus VA plus VA. So this VA will be cancelled out. With this one, we get the value of V naught. So one method is to put t is equals to 0. So if we put t is equals to 0 in this equation, so our Vc at 0, this will be equals to 20 e raised to power 0 minus 10. So this will be equals to 10 volts. So our first answer is V naught is equals to 10 volts. Now we want to calculate the value of tau. So you already know that t by tau is equals to e raised to power minus t by tau. Here we have an equation. In our equation is equals to e raised to power minus 200t. So taking natural log on both sides, we get minus t over tau. This is equals to minus 200t. So this minus will be cancelled out by this one, and this t will be cancelled out by this one, this t. So we have tau, that will be equals to 1 by 200. So this will be equals to 5 milliseconds. This is very easy. Now we have calculated the value of V naught. Now we want to calculate the value of VA. Again, we have the equation. How would we calculate? As you already know, by comparing two equations, one is generic. This VA should be equals to this voltage. So just by comparing these equations, we know that your VA is equals to minus 10 volts. Another method is to put times t is equals to infinity. It means that when your capacitor will be fully charged, and this is the forced response, it means that you get the value when your source is completely have charged your capacitor. So putting t is equals to infinity. So our equation will becomes Vc of Vc at infinity. This will be equals to 2 e raised to power minus infinity minus 10. So this factor will becomes equals to 0 because e raised to power minus infinity, that will be equals to 0. So this will be equals to minus 10, and this is equals to our VA. So this way, or by comparing equation, you always get the same answer. Now we have calculated three things. One last thing, at what time t Vc will be equals to 0. So that is again very easy. We have this equation, the input voltage Vc of t. We will equate this voltage to equals to 0. So we have part number 4, 20 e raised to power minus 200t minus 10 is equals to 0. So we have 10 on the other side. So 20 e raised to power minus 200t is equals to 10. So we get e raised to power minus 200t. This will be equals to 0.5. Taking natural log on both of the sides, what we get, time is equals to natural log of 2 divided by 200, and this will be equals to 3.47 milliseconds. So this is a very interesting and very easy example to evaluate our equation. So in our next lecture, we will perform some more examples and some more topics will be coming. So for that, and I'll see you soon. Thank you.